Okay, all right. So let's do the practice midterm. I'm going to start with a true or false. So first, I have that if f is a continuous function, then fbt is a martingale. And the answer to that is false, because I know that bt squared is not a martingale. All right. Now, question B, if I take the expectation of bt to the 8, then it's 8 factorial times t to the 4. This is also false. Why? Because bt to the bt is a normal 0t, and we know the moments of a normal 0t. So in fact, it's always multiplying the odd numbers up to the power. So bt to the 8 is actually 7 times 5 times 3 times 1 times t to the 4. So we get t to the 4 because the variance is t, okay, just by normalizing. Okay, now C, if bt is, here again it's empty. If mt is a martingale, then we always have mt minus ms, and the conditional expectation of that given fs is 0, and this is true because this is just a martingale property that mt given fs is equal to ms in disguise, because I just put ms back in the expectation. I can do that because ms is fs measurable. Now, the expectation of bt to 101 times bs to 100 is 0, and the answer to that is true, because we know that Brownian motion is symmetric. So if I take minus bt the whole path and I reverse it, this is also a Brownian motion. So the expectation, I take minus bt and minus bs, and the trick here is the even power gives you 1, and minus 1 to an odd power is minus 1. So this equals to minus itself. All right. Okay, let's move to the E. And if I have a Gaussian vector with a covariance 2, 1, 1, 3, mean 0, then the random vector AXY is a Gaussian vector for any 2 by 2 matrix A. And the answer to that is true, because this is just a linear transformation of a Gaussian vector. All right. Now, question F. I have a Gaussian vector again, xy, then the random variable x and y minus x over 2 are not independent. So now they're jointly Gaussian. To know if they're independent or not, I can compute the covariance. So I'll do that. So E of x times y minus x over 2. Okay, the mean is 0, so that's the covariance. This is E of xy minus E of x squared over 2. And now this is the Gaussian vector above, so I can replace the value of the covariance, given in the covariance matrix. So this is equal to 1 minus, and the variance of x is 2, so minus 2 over 2, so it's 0. So they are independent, so this is false. All right. Now for the second one, G, I have again a Gaussian, and it's not necessarily a Gaussian vector here, it's just a random vector, x1, x2, x3. Their variables are square integrable, they have second moment. So we always have the conditional expectation of x3 given x1 is the same as first conditioning on x2 and x1, and then by x1. So I condition on more information than on less, so I can always do that. This is called the tower property of the conditional expectation. All right, so this is actually true. The question H, the random variable max of BS from the maximum of BS on the interval 0, 1 is heavy tails, since expectation of maximum is equal to infinity. So this is, I'm going to write it below, so H is actually false, because this is what we know, that the maximum on 0, 1 of BS has the same distribution as the endpoint, which is just B1, the absolute value. And the expectation of the absolute value is not infinity, so this is false. All right, now at I, consider the random variable x, which is the stochastic integral of bs squared times bs. We haven't seen it yet, but we'll see it, so let's just answer the question. Then x is bigger or equal than 0 with probability 1, and the answer to that is false. Why? Because so what you have is that by definition x is the limit when the partition gets fine of the martingale transform. So it's the sum over j xtj times the Brownian increment. All right, and here xtj is actually the strategy, and the strategy you're integrating is bs squared. So here I have btj squared. So this is positive, but this might be negative of positive. So this sum is not always 0. Okay, so actually this guy is not necessarily 0. So this is false. Okay, and then the last one's not true or false, but it's a short answer. I have two graphs. They represent 50 paths of two stochastic process. Which one is a martingale? Again, a martingale is constant and average. This guy, on average, if I look at all the paths, it's increasing. So this guy is a martingale. All right.